Now that we've taken care of that, let's get started on today's episode. Lithium titanate battery, LTO. The chemical formula is Li2TiO3, and the anode material, lithium titanate. It's a rechargeable battery that has the advantage of charging faster and a longer life cycle than other lithium-ion batteries. The first question, what's the pricing advantage of an LTO battery? To highlight the price advantages, making comparisons between the same voltage of 40 AH 3.2 volt, the price of the LTO battery is $38.70 US, which is nearly $10 US cheaper when compared to the price of $48.58 US for a lithium iron phosphate battery. That's your LiFePO4. In addition, you'll save another $13.95 US by purchasing an electric car using the LTO battery instead of one using a lithium-ion battery at $52.65 US. To be honest, the price of electric vehicles will be influenced by reducing battery price. Therefore, when a product's powered by any type of battery, the price of that battery determines the price of the product. So what stands out about the life cycle of an LTO battery? The life cycle of these batteries is impressive, exceeding 30,000 cycles during cell life, which is 60 times more than competitive lithium-ion technology like lead acid, which is 500 to 1,000 cycles. Furthermore, LTO batteries are making 10 times distance from lithium iron phosphate, and that's like 3,000 to 5,000 cycles. On the other side, the cycle life of LTO batteries gives it a lifespan up to 82 years. That's higher than 27 times of lead acid batteries, which have a life of 3 to 5 years. And it's over 4 times higher than that of a phosphate battery with a lifespan of 20 years. The test below will partially demonstrate why they're so efficient. When the battery's discharged at 2C, the LTO battery can still function normally as a daily duty cycle. That means that voltage has no effect on the battery during operation. As a result, it can be grouped alongside other long-life infrastructure such as transformers, transmission lines, and generators, and doesn't need to be replaced for an extensive period of time. The second reason is that, unlike other types of lithium-ion batteries, the LTO battery has a life cycle of up to 82 years because charging and discharging rates have little effect on them. They're suitable for all charge and discharge rates ranging from 1C to 3C. Overall, LTO batteries have the longest cycle life of all batteries, and the testing results are proven that no battery failure occurs up until about 82 years of lifespan. So how does Tesla plan to use this long-lasting battery? As Elon Musk stated, the price of lithium's risen to an absurd level in order to fulfill future demand for batteries. Tesla intends to conduct research, explore, and manufacture batteries to fulfill Tesla's own needs as well as those of the EV industry in general. Using titanium material in combination is one of the most realistic strategies of lowering battery cost. Combining lithium and titanium material to create a new type of battery not only reduces cost but improves battery quality. Specifically, the price of titanium in December 2022 is $4,101 US per ton. That's less than 9 times of lithium at $37,000 per US ton. As a result, when compared to present pricing, this combining material will save a significant amount of money in production cost. Furthermore, lithium batteries combine with titanium, which greatly improves durability and life cycle, because titanium is unaffected by environmental factors like resistance, pressure, and operating in a wide thermal range. To achieve the goal gradually, Tesla's invested over $10 million US in building their own factory. That plant is built in Nevada.
Over 5 million square feet, 11,000 team members, and we have 3,200 acres of adding another 4 million square feet of manufacturing space, and at least 3,000 jobs, direct jobs, and I think it'll probably end up being more than that.
The plant is outfitted with cutting-edge technology for refining and producing batteries. It's certain that this is Elon Musk's big footprint marking Tesla's battery technology in the EV industry. Next, what advantages do these LTO batteries provide in terms of charging and discharging? When compared to traditional lithium-ion batteries, they take about 2 to 3 hours. But the LTO battery can be charged 18 times faster in 10 minutes. LTO batteries are the sole option for high-speed charging because LFP technology does not permit continuous high-speed charging and discharging. The maximum charging and discharging current for this battery is typically 10C, which is 400 amperes. The standard lithium battery has no charge and discharge capacity below 0C and cannot function correctly, whereas the lithium titanate battery has a charge and discharge conversion efficiency of 86% in a temperature range of minus 35 degrees Celsius to 70 degrees Celsius. The performance is significantly better than 95% or higher. On the other hand, the lithium titanate battery utilized titanate nanocrystals instead of carbon on the anode surface. This provides the anode with a surface area of around 100 square meters per gram compared to 3 square meters per gram for carbon. That allows electrons to enter and exit the anode quickly. Furthermore, the redox potential of Li plus intercalation into titanium oxide is higher than that of Li plus intercalation into graphite. Because the charging current is higher, this results in faster charging. Lithium titanate cells last for 3,000 to 7,000 charge cycles. There can be a life cycle of approximately 1,000 cycles before reaching 80% capacity when charged and discharged at 55 degrees Celsius, equivalent to 131 degrees Fahrenheit, instead of 25 degrees Celsius, which is 77 degrees Fahrenheit on the standard temp. Furthermore, during the cycle, the volume change of lithium titanate batteries is only 0.1% to 0.3%. This can help to avoid structural changes due to material elongation changes while charging and discharging. As a result, the electrode's performance improves and the substantial attenuation of the specific capacities reduced. The cycle process does not produce an SEI film. Other lithium batteries experience a 10% volume expansion during cycle, resulting in battery swelling and the formation of passive SEI film on the electrode surface. Both of these will significantly reduce the battery life. Furthermore, when compared to carbon anode material, lithium titanium has a higher lithium ion diffusion coefficient. The lithium titanate battery created using cutting-edge technology can be fully charged in 10 minutes. This is a tremendous step that no conventional battery can make, because excessive charging time has always been an impassable barrier in the development of electric automobiles. For example, a typical electric bus has a charging time of as little as 4 hours. Instead, that can be shortened 24 times with a charging time of 10 minutes for a full battery pack. Fast charging for electric vehicles is always the future trend, and buyers do not want to wait for charging for an extended period of time. Next, what is the LTO battery's capacity to reach that rapid charge rate? The LTO battery 40AH weighs 250 grams less than 630 gram with a 40AH LFP cell at 880 grams. However, the energy density is relatively the same because the LTO battery has a nominal voltage of 2.3 volts, which is less than the 0.9 volts with an LFP cell at 3.2 volts. The battery's construction is a critical aspect in its success. It employs the utilization of 2 battery terminals. The first component is an anode. Instead of employing carbon on the anode surface, LTO batteries use lithium titanate nanocrystals to improve surface area. This permits electrons to flow faster in and out of the anode than in normal lithium-ion batteries. The cathode comes next because lithium titanate is employed in a double-layer cathode. These fuel cells have 2 material layers, Layer 1 and Layer 2, which enable the manufacture of high-power molten titanate fuel cells to perform more efficiently.